Hi, this is Brett Robley, and I am going to talk in this lesson about going from C or C++ source code to executable code. C and C++ programs are written in a human-readable source code and saved as text files, usually with a .c or .cpp suffix. Programmers use a programmer's text editor to create unadorned text files. Every hosted C and C++ program must have one and only one main function. Functions other than main are invented by programmers, but for this class and for most C and C++ programs, processing starts at the main function and proceeds sequentially down the page from top to bottom, or until the flow of control is altered by the programmer's code via decision statements or looping statements. Now, some functions other than main will be created by you, but many come with the compiler packaged as libraries, providing all manner of different capabilities for your benefit as a programmer. To gain access to these libraries or this functionality, you include references to header files that then call in or set you up to call in this functionality. So an example of pre-programmed library functionality would include things like file input and output, string manipulation, and math routines. So C and C++ programs or source code go through a transformation process, converting human-readable C source files into machine-readable ones and zeros. This is accomplished by employing a C or C++ toolchain, which is sometimes nicknamed a compiler. C and C++ toolchains are groups of complex computer programs developed and refined over more than 5 decades. So there's a lot of technology that goes into this. So generally speaking, when a programmer submits source to the C or C++ toolchain, we call that compiling usually, even though there's more phases than compiling. The files are processed first by the C preprocessor. Let me pull up a picture for this to give you a visual. So we edit C source code. That's what step 1 is. The preprocessor gets called and does some simple symbol replacement. The compiler gets called and converts the resulting text source code into zeros and ones. That's the object code. However, because we are usually naming libraries and library functions that we want to use, we then need to go to a linker phase where the linker goes out and finds all the code that we said we want to use, like printf and putS and scanf and those types of function calls. And so it goes and finds that code, which are in static libraries or shared libraries that are provided with the compiler or with the operating system like Mac OS X or Windows or Linux. And so the linker goes out and finds all of these missing pieces and adds it to your code, sort of. And then that's an executable file is created. So in the Windows world, it will end at a .exe, and in the OS X and Linux world, it will possibly end with a .out, or it might not have an extension at all. So static libraries are linked at the linker phase, but shared libraries are connected to your program's code at load time. So once you've gotten through the linker phase, you have an executable file sitting in a folder somewhere on your disk. And when you invoke that executable, when you name it on the command line, then the loader takes over and it opens up your code, and then it does some resolving, trying to find the functionality that you want to bind with your code. But it does it at load time rather than at link time. And then once the loader resolves all this, it kicks off your program, and your program starts running. Okay, so there's a lot more to it, and this is not a computer science class, and so I'm going to just leave it at this. This will suffice for our purposes, just to give you kind of a behind-the-scenes understanding of what goes on when you invoke the compiler. So let me give an example real quick. Let's write a simple hello world program, and I want to demonstrate first the preprocessor functionality. So with the preprocessor, I can use a pound define followed by a space followed by a symbol I just invented. I call it MSG for message, and I will write the usual hello world text, only I will do it as a symbolic constant. Then I'll come down here, create my main function, and then I'm going to say I want to put this string out to the screen, and voila, I've currently, for now, I'm ignoring the include standard IO because I want to show you what this does. So now we have this hello world.c, and now what I want to do is I want to call the Clang compiler, only instead of putting it through all its phases, I'm just going to call the preprocessor. And so that's what the -E is. And when I do, I end up with a different output. You'll notice up here where I have the pound define message and this string, that's gone. But notice that the string was inserted where before it just made reference to the symbol message. And so that's what the preprocessor does, is it takes my defined symbols and it replaces them in the code, and they go away. Now let me demonstrate what happens when you include standard IO or some other header file. So I'll go ahead and say pound include stdio.h, and that tells the preprocessor, hey, go find the standard IO.header or h file, which is the header file, and that header file gives we programmers access to routines like printf, puts, etc. Okay, and that's why we include it, so that we can actually use this functionality. And now I'm going to save it. I'm going to clear the screen, and I'm going to show you now when I call the preprocessor with hw.c, I'm going to have a lot more lines of code because it's going to include system code to help me with my programming. So if I run this, it looks like I got a blank screen, and I'll back it up and notice here's our program, but now it's got 537 lines before my main function, which the preprocessor called in because these are all the headers that we get when we include standard io.h. So you see you get a lot of code that refers to things that we'll never understand. We just rely on printf and puts to put things out on the screen, and that's how that works. So now if I were to compile my code normally, clang hw.c, and I'll call the output file hw.out for hello world, compiles it, and then I run hello world.out, and notice how it says hello world. And so there's our executable code that has been translated according to that model that I showed you. We edit, then we get out of the editor and we call clang, which calls the C preprocessor and does symbol substitution, calls the compiler, converting source code to ones and zeros, that's our object code, calls the linker for any static libraries, which I don't expect you to understand, it creates an executable file. Then we try and run the file. It calls the loader to load the file into memory and also resolve any shared library references, and then it kicks it off and it starts executing. And that's what step 6 is. Okay, that's all for this lesson, and I hope this is helpful.